In this chapter, we will learn how to light the environment. We will do a nighttime lighting so that it will look effective for the VFX effects and character lighting. I will use the default Asian village map for this chapter. You can use your own level. First, let us remove all the lighting related assets in the level and do fresh lighting. Remove the exponential height fog. Remove the directional light. You can see the type of the light in the right side. The display name may be anything. There is a dependency for the directional light with the blueprint sky sphere used for lighting. Confirm, delete it anyway. Next, remove the sky sphere blueprint. Remove the skylight. There is one more mesh SM_sky. It has a material assigned for the sky. We will remove this static mesh actor. Remove the light mask importance volume. Remove the post-process volume. We will leave the point lights. They are for interior lighting. If you want, you can also remove them. Remove all the sphere reflection capture actors. We will have a simple system for the night lighting. So we won't have sphere reflection of the light. We will use a HDRI texture based sky. For this, we will download a free HDRI texture from Polyheaven website. Select skies. Under that, select pure skies. These textures have only the sky. We will use the Belfast sunset in this chapter. Choose HDR, select 2K and download the texture. In the Asian village folder, create a folder lighting. Import the HDRI texture into this folder. Next, we will create a sphere actor and make it huge, which will surround our level. Then we will apply a HDRI material to the sphere and it will appear as a sky around the level. We will do this step by step. First, let us create the material for the HDRI texture. Create a material, name it M_SkyMat. Open it. Select the node. Choose unlit for the shading model. Select two-sided as true. These settings are very important. Apply the changes. Drag and drop the HDRI texture to the material graph. Let us make this as a parameter so we can change the HDRI texture from the material instance. Right click, convert to parameter, name it HDRI. Press the 1 key and left click. You will get a node with a single float value. Convert to parameter, name it sky brightness. Multiply the HDRI RGB output to the sky brightness. This way, we can increase the brightness of the HDRI texture. Next, we will provide a color variation to the texture. Press the 3 key and then left click. You will get a node with RGBA input. We can use it for color information. Make it a parameter. Name it color variation. Choose a default color value. From the multiply output, add another multiply node. Connect the color variation to that. From the second multiply output, connect it to the emissive color. Next, we need to provide the UV details to the HDRI. For this, add a rotate about axis node. Press 3 and left click. In this, add the Z value as 1. So the rotation will be around Z axis. Connect the output to the normalized rotation axis. Add a single float value node. Make it a parameter. Name it rotation angle. Connect it to the rotation angle. Changing this value will rotate the HDRI texture. To the pivot point, connect a single float value node. Leave the default value. Add an absolute world position node. Search for world position. Don't search for absolute world position. Use the output pin XYZ and connect to the position. To the output of the rotate about axis node, add the absolute world position output and then connect the output to the normalized node. Finally, connect the normalized output to the UVs. Normalized node convert the output to a unit vector. Apply the changes and make sure there are no errors. Also, set a default value of 1 to the sky brightness so that you can see the preview of the sky texture. You can rotate the output and view the HDRI sky. We are done with the material now. Right click the M sky mat, create material instance. Name it MI sky mat. Open it. I will keep the rotation angle as 0. Sky brightness as 0.5. We are creating a fairly dark environment here. Color variation, choose a color of your choice. HDRI, I will leave the defaults. In the level outliner, create a folder lighting. Add a sphere to the level. Name it sky sphere. Move to lighting folder. We will keep the lighting related actors organized in this folder. Select sky sphere. For the scale, set the lock icon for all the axes to be the same. Set the scale as 10,000. Set the material as MI sky mat. You can see the sky now. We need to make sure there is no collision in this sphere actor. Search for collision. For collision presets, select no collision. Next, set cast shadow as false. Save all. Next, let us add the directional light. The directional light is the main source of light, the sun or the moon. In our case, in night lighting, it acts as the moon. Move the directional light to the lighting folder. Make it movable. It is very important for dynamic lighting. Intensity set to a low value. I will add 4 lux. Light color, keep it dark bluish gray for night lighting. You can have your own choice. Next, add skylight. Skylight reflects the directional light and distributes it into the level. Move the skylight to the lighting folder. Make it movable. Light color as dark bluish gray. Click recapture to reflect the changes made. Next, the most important ones. Add a post-process volume. Move it to the lighting folder. Under post-process volume settings, set infinite extent to true. This applies the post-process effect to the entire level. You see a volume box for the post-process volume. If you set infinite extent to false, then wherever you place the box resizing it, the effect will be applied only there, mainly for interiors and specific areas. We will use it for the entire level, single setting. Under exposure, min EV 100 minus 3. Max EV 100 5. You can see the exposure is locked to a value throughout the level now. Adjust the exposure compensation value to minus 0.75. Now we start to get a uniform value across the level which can be changed. Next, we will add the final but an important actor, the exponential height fog. Move it to the lighting folder. Set the fog density to 0.01. Fog height fall off to 0.07. Fog in scattering color as dark gray value. Volumetric fog as true. Emissive value as dark gray. Make sure you keep the alpha value as 0. Now you can enable and disable the different light actors and see what differences they make to the lighting. That is the most interesting way to learn the process. Do a recapture once in case the changes are not reflected in the skylight. In this scenario, there is not much impact by skylight. As we left the point lights early, one of the point lights you can see in the exterior. You can see the difference it makes by adding the additional lights now. Point lights and the spotlights can be added to the light props to enrich the level. Next, let us add the second level prop lighting using emissive colors, point lights and spotlights. You can see a lot of lanterns in the level, but they are not on. Let us switch them on. In the folder meshes props, open sm lamppost underscore 03. You can see the light switched off. The material for this is mi lantern oven inst. Open it. The parent material for this is m underscore lantern. Open it. We won't make major changes to this material. You can see the texture for the lamp portion. Open the texture. In this, the alpha layer has the information about the lamp area. You can disable R, G and B. Keep only A enabled just for testing purpose. You can see the black color is the lamp portion. Back in the material, to get the lamp portion, you can use a node 1 minus x, which will reverse the value from 0 to 1. Let's skip this for now. Let us get the emissive color to display. Press 3 key and left click. Add the node. Convert to parameter. Name it emissive color. Select the color as something like orange. Add a single value float node. Make it a parameter. Name it emissive intensity. Set the default value as 0.2. Multiply both using the multiply node. Get the output and multiply again with the output from 1 minus x node. Connect the output to the emissive color. Apply the changes. Now you can see the light is glowing. In the blueprints folder, create a new blueprint with parent as actor. Name it BP lamp post. Open it. Add a static mesh component. Set the static mesh as SM lamppost 03. Add a point light. Adjust the position to be at the center of the lamp. Set some default value to the intensity. Anyway, we will set the value dynamically. Set the light color to orange. Add a spotlight. Set the rotation Y value to minus 90 degrees. Adjust the position somewhere to the top of the lamp. Set the intensity to some default value. Set the light color to orange. Next, in the construction script, get point light and use the function set cast shadows. Promote the new value pin to a variable. Name it point light cast shadow. Keep the default value as false. Get spotlight and use the function set cast shadows. Promote the new value pin to a variable. Name it spotlight cast shadow. Keep the default value as false. Get point light and use the function set intensity. Promote the new intensity pin to a variable. Name it point light intensity. Keep the value as 2500. Get spotlight and use the function set intensity. Promote the new value pin to a variable. Name it spotlight intensity. Keep the value as 5000. Compile and save. Finally, expose the variables as instances editable so that you can change these variables from the level. We are done with the blueprint. Place this blueprint actor in the level. You can see the lighting from the lamppost blueprint. You can adjust the values and see the effect. And also, you can see all the lanterns are glowing now. The reason is all the lamp related static meshes are using the same material instance. You can adjust the emissive intensity value to 0 in a separate material instance if you want to switch off some lights. Same way, you can set other dynamic actors with lighting to enhance your level. Welcome to the course Unreal Engine 5.6 Build an Action RPG using Lyra framework. In this course, you will learn the core features of Lyra framework from scratch in a week with all free assets from Fab Marketplace. In this to-the-point step-by-step practical course, you will learn the skills to develop melee, archer and magic abilities. We will start the course by creating a new game feature plugin RPG core with an RPG experience. You will learn the foundation of Lyra locomotion by building a simple, lightweight Lyra-based locomotion system from scratch. We will use the free Mixamo animations, add root bone, and build different weapon animation layers. We will create a simplified extendable gameplay attribute system with health and stamina attributes to learn the core gameplay ability system. The Equipment Manager and the Inventory Manager are covered to equip swap weapons. Inventory Fragment system is covered from scratch, which is the foundation to build any type of inventory system. Approach to create new weapon textures is covered for the quick bar. Interesting ideas to craft your combat system using animation notify system and gameplay events. You will build melee attacks which can be interrupted with weapon tracing techniques. advanced bow and arrow system is covered in this course. We will also build an AoE attack system for the boss enemy. Free Niagara effects are used and techniques to convert cascade effects to Niagara is covered. We will build a step-by-step artificial intelligence system for the enemies using state trees. You will learn how to build the main menu with a level background, learn use cases for UI materials and animations. You will also learn to create your own multi-layered RGBA mask textures for the logo. Apart from Lyra starter game, you will learn innovative approaches to reuse and customize marketplace assets to build unique assets for your games. Learn skeletal editor to modify skeletal meshes. I have also provided my level creation tool for artistic needs. It is provided free to use in this course. It is a complete blueprint based tool with lots of automation features to build huge environments in no time. This course will be periodically updated with more features related to RPG. The core idea behind this course is to build the research skills to explore a detailed framework like Lyra. By the end of this course, you will get a good knowledge in the Lyra framework to start building your own game.